Well, welcome to today's project, and it's a little bit different because there's no code. We're going to be looking at wiring. This stuff. Now, why are we looking at wiring? Well, I can tell you now, of all the projects that I've helped people with, I reckon 70% of the issues that I come across are due to wiring. Bad connections, not following the circuit diagram, you name it, this causes problems. And the reason that this is important is you can spend hours trying to sort your Arduino code out when actually your code is working. Your problem is your wiring. So let's take a look at wire. Now, this is just one of my boxes of wires. As you can see, there are all sizes in here because you need different sizes for different things. So what we're going to do is go through bit by bit how we start projects and how we actually finish up with fully working and soldered up projects. So for most of us, when we first got into Arduino, we finished up with a box full of these DuPont and solderless cables, these little things that you just push in, and we will have had some breadboards, and obviously we build our projects up. Now, getting your wiring right is actually quite important, as I'm going to show you. I'm just going to move this out of the way. See what I've done to my breadboard? That was through bad wiring. That was where I was using a NEMA 17 stepper motor and I didn't have a good connection, and it started sparking and started to melt my breadboard. So this is why wiring is important. So this is obviously the basic setup that we all sort of start with, and what we tend to do to power our project is we use the 5-volt pin over here to power our projects. Now, as we'll see, that is not an ideal situation. So I'm going to move back on now to my modern project board. So apologies for the mess on the desk. This is a project that I'm actually working on at the moment, doing some tests on servo lead extensions of all things. So you can see that I've got my Arduino over the top, but the only thing that's connecting the Arduino is these two signal connectors and the ground. The power supply now is coming from this second breadboard power supply, and I can tell you now, these are pretty much essential when you're beginning, because your Arduino is not designed to power a project. We'll have a quick look at some figures and you'll start to see why. So, power supplies. Let's have just a quick look at what the various boards can do. I've just listed 3 here. So you've got an Arduino Uno that can push out about 20 milliamps per pin. And if you're connected to your USB supply from your computer, you can in total get 500 milliamps, that's half an amp, 800 milliamps if you're powering it from an external power supply through the sort of jack plug connector on the thing. Now this is important, this 500 milliamps here, because now and again you will get situations where for some reason you cannot connect to your Arduino because it's, giving you a COM port problem. This is very often if you've put too much load on the USB power supply. If you're fortunate, it will disconnect your COM port. If you're unfortunate, it might do some more damage than that. So again, when we start to think about what we're doing, how much power we're using, and 500 milliamps, as we'll see, is not much. If we go down to this bottom table, an SG90 servo, or is it an SV if you've got the plastic one, the light blue one, same thing, same internals. Those things, when they're running at max power, when they're really having to push some load at maximum torque, they will require 450 milliamps. Now think about that, 450 milliamps, and off your computer you can get a 500 milliamp supply through the USB connector. So if you're going to run 2 servos and a servo driver board off your breadboard through your computer, well, don't be surprised if your COM port suddenly disappears. As you can see, that's where you start to need the external power supply. Again, you've got the Arduino due, about 3 to 15 milliamps per pin, depending which one it is. Again, the same overall. And ESP32 dev module, I've just put out that in there, 20 milliamps. Now, on some of these, you can push them up to 40 milliamps. You've got the 2 here. However, you are pushing the boards to the limits. When you're seeing these maximum figures here, obviously the 500 is because your computer's not going to be able to give any more through the USB, but this 600 and the 800, this is all to do with the limits of the voltage regulator on your board. Basically, it's not designed to be a power station. So what you need to start to do is, when you're doing your Arduino projects or your ESP32, think of your board as the signal generator, the brain of the project. Your external power supply is the brawn of the project. That's giving, the power, but the brain is just running the system. If you think of your projects that way, your projects will run well. And then as you build your project, what you need to do is make sure that everything, basically each component is being supplied from the power supply. If you're just putting LEDs in, you'll get away. You could put a LED in each pin in an Arduino Uno. You're not going to have any problems because an LED, as we can see, is within our power range. However, if you were going to start to add sort of hundreds onto the system, again, it's not going to work. So just get that idea that your Arduino board or your ESP32 board, that's the brains of the project. Your external power supply is the brawn of the project, and that's what we need to be powering the project. So going back to the breadboard that I'm using most of the time now, this external power supply, I can supply 3.3 or 5 volts depending on the way these header pins are set on this rail and this rail. So basically I've got a 5 volt positive and a 5 volt negative. So you can see my red wires off the positives, there's a black wire off the ground. One other thing, you'll notice I've got 2 boards here together. You can take the one edge off the board and the 2 boards will actually clip together. For those who use the dreaded ESP32 dev module and have ever tried to put it on a breadboard, because you can't get any wires in here because it's too wide. If you put 2 boards together, you can have one set of pins this side, one set of pins this side, and there's still room to get your solderless connections in. So those using the ESP32 dev module, get 2 boards, stick them together. But of course we don't want to be building permanent projects. These are great for experiments, but when we want a permanent project, we need to build something far more solid. Now, very often when I'm looking on different forums, when people want to build a more permanent project, they are often told, well, you've got to have a circuit board made. What a load of rubbish. Now, I'm not saying that having a custom built circuit board is not a good idea. And if you want to build hundreds of something, I'll be honest, even sometimes if you need to build 10 of something, it's worth having a board made. However, a lot of the projects you build will be one-offs, and for that you don't need a custom built board. And even if you are thinking of a custom built board, it's still worth knocking something up on a piece of Veroboard. So Veroboard is basically circuit board with little bits of copper on the board, so that as the pins come through, just like your breadboard, you can. So if you look at this one, this is a project, this is the other side. So if you like, the pins go through and you solder on the bottom. So each of these plugs is going through and I've soldered the different connectors. This is some 2.54 headers that a DF mini player sits in. You'll notice I use a variety of connector sizes, and here is the screw terminal where the external power supply comes in. Now, a little tip for you here. You will notice that the one terminal is red. That is red nail polish, nail varnish, whatever. I scrounged it off my wife. One of the best things you can ever buy yourself if you're knocking up a project is red nail varnish. It's absolutely superb stuff. Put it on the terminal that is the positive so that you don't confuse it, because obviously these blue screw connectors, they've got nothing to say which terminal it is. So mark it up in red, and that way you know that is the positive. And if you look at a lot of my projects, you'll see exactly the same thing happening. Now, this ESP32 dev module, you can't quite see it, but that again is sitting on these header boards. Now, when you order VeraBoard, as you can see, here's a pack that's just arrived. There's two types. There's this type that has the individual solder spots. There's another type that has strips. Unfortunately, I haven't got a brand new board. As you can see, this is just a bit that I'd got knocking around. For one project, this can be an advantage. For other projects, this can be an advantage. These days, I'm tending to use the one with the individual dots. With these, you might put your board across. If you can imagine, it's longer. Your pins going this way, and then you have to get a scriber and sort of scratch through the copper to put a break in it so that you don't short across the pins. These days, I'm just finding this method is easier. Now, pity you can't see the back of this. These plugs, they are all for PCA 9685 boards. The pinout is identical, so underneath I'll actually have a piece of metal, piece of wire that goes between the pins going horizontally, so I'm creating a bus bar effect to power all of those. And I'll do a separate video on connectors because they're quite an important thing to think about. Another way, instead of using this type of VeraBoard, is to go to a prototyping shield. So this shield literally plugs on top of your Uno or your Mega or your Arduino Duo. You can get longer ones for the Mega or the Duo, and obviously that gives you far more space to work on. As you can see, this one has some, this is a DCC decoder circuit and a stepper motor driver and various headers for the stepper motor and various bits to come off of. These boards work extremely well, and I've even used these on one industrial machine. I've got one of these on an Arduino Mega on a bag filling machine that I built about 4 years ago for a company, and it was only a temporary prototype. 4 years later, that thing is still in there. It goes through all sorts of vibration, dust, powder, plaster all over it, freezing cold, boiling hot. That thing's been running faultlessly for years. And the great thing about it is, if I need to do any mods, I can just take the thing off and solder some new bits on. And we do actually have an upgrade for that board coming. So this, if you like, is your next step in producing your board. Again, you've got to think, how is your power supply coming in? And your power now comes to your VIN pin on these boards. Do not power your projects through the USB sockets. It's a really bad idea. And be honest, if you're trying to power a ESP32 dev module through this, you'll be lucky if it survives a week, because these USB connectors pop off so easily. So power it through the VIN pin. You can power that with about 6 volts. What you want to be looking at realistically for an ESP32 is about 1.5 volts, higher, maybe less, 5 volts. It's a 3.3 volt pin, so if you're 1.5 volts over what the output is, you'll be fine. if you're using an Arduino and you're going in through the jack plug connector, then you can put sort of realistically 7 to 12 volts through there, and it's going to be quite happy. And if you can sort of get yourself a, what they call them, buck converter, something like that, that's a good way to get your 5 volts again for the rest of your project components, rather than just trying to take it all off the Arduino. Now, one thing I do want to draw your attention to here is you can see where I've got this unit plugged in. Notice I've got multicolored wires, and what I would say to you is get as many colored wires as you possibly can. Now, the good news about multicolored wires is you can get them for free. That's right, free. You do not need to go and buy reels and reels of cable. As you can see here, I've got, I think this is an old monitor cable, and what I do is I slash the insulation just a short distance with a scalpel, and then basically I yank the wiring through it, and depending on which type of cable you're pulling out, you will get lots of lovely colored wires. If you can find them, the old parallel serial, the parallel printer cables, they are absolutely superb. I think you can get about 20 different wires out of one of those. Absolutely superb cable. But even this one, this I think it's a VGA cable, something like that, it's probably got what, 8, 9, 10 different colors in there. So I have a whole box load of stuff, and what I do is, and I'd advise you on this, unless you've got reels to put this stuff through, only slit the insulation as far as you need, cut off what you need, and then leave the rest of it in the sheathing, the outer sheath, because that way it doesn't all get tangled up. But keep an eye out for all these old cables, because you'd be amazed when you open them up. There's a different type of cable here. I forgot what this actually was, but as you can see, it's got some thicker ones, but again, some thinner wires within there. So multicolored wires, you can actually get these things for free. Yeah, just keep an eye out for any cables that are being thrown out. Now, obviously, if we're going to be soldering stuff up, we're going to need a soldering iron. Now, this is my big beast of a soldering iron. Got the soldering iron on the left, that's actually a desolderer on the right. I'll be honest, this unit cost about 150 quid, and it is absolutely superb. However, in my garage, I use one of these cheaper nasties off Amazon. There's one here, 9 quid. And that's very similar to what I've got in my garage. The reason I use that one in my garage is this thing weighs a ton and I'm not going to move it around. So it's great on the desk, but it's useless for crawling under my model railway. So I have a cheap and nasty in the garage, and I'll be honest, I probably break it every 12 to 18 months. I don't care, it's 9 quid, I'll buy another one. This unit has been absolutely superb, but I'm just going to talk to you about some accessories that are well worth having. The first thing is the stand on the left. Now, this was a really nice unit, and I'm going to be honest, this stand weighs a ton. Some of the soldering irons you get come with a really lightweight soldering stand, and that makes your soldering iron very, very unstable. And let's face it, if you've got a big cable coming off your soldering iron, it's easy to have it sort of starting to get a bit of a twist on it, and if the stand is light, the next thing it's going to flick over and it's going to fall in your lap, and that's going to be a bad day, a really bad day. And I can tell you, reaching out to grab a hot soldering iron, you're going to grab the wrong end, bits are going to get burnt that you don't want to think about. So if your soldering iron comes with a really lightweight stand, what I'd say to you is nail a piece of wood on the bottom of it, and if you have to add extra weights to that piece of wood, do it. That's exactly what I've got in the garage. So I've got a cheap and nasty soldering iron with a cheap and nasty stand, but it's nailed on a block of wood, and again, it becomes very stable. Next thing, in the center here, we've got this gold ball of fluff. This is a solder tip cleaner. As you can see, that one's £6, £4, whatever, about a fiver. These things are really good for cleaning the tip of your soldering iron, and keeping the tip of your soldering iron in good condition is really important. It really does prolong the life of the tip, so well worth spending the money on that. Obviously you're going to need solder. I tend to buy it in big rolls from in the UK. I buy it from Screwfix, to be honest. Another thing very useful to have are these extra hand type things, crocodile clips on a extendable arm. These come with a magnifying glass and all the rest of it. Well, that gets thrown away within the first 30 seconds. But having these things are absolutely fantastic unless you have grown a third arm. Really worth having to hold components in place. One other thing that I haven't got a picture of here is I wear a headset magnifier. Again, these are about 15 quid, I think, off eBay, and really, really useful. Let's be honest, I'm getting on in years, my eyes aren't so great, and it's just nice to have something that I can really see clearly. The other thing to be aware of, you'll notice the light is quite good where I'm working. That's because above my workbench I've got some LED cob lights, actually built like a lighting bar, to make sure that I work under very, very bright light. And of course the other essential, you can see it there, that's my red nail polish. Yes, everybody needs red nail varnish. So those are the basic tools that you need. Other odd things that are quite useful, bit of blue tack can be quite useful at times, just to hold things in place. Funny what you can use it for. If you noticed earlier on one of my projects on the, where are we? On the breadboard, you notice here I've got some blue tack around the pins going into the Arduino. Let's be honest, these pins aren't always exactly the best. They can easily pop out. So very often if I've got pins that keep popping out, I'll just put some blue tack around them and stick them into place. So that is the next part of our project, soldering it onto the Vero board. With your processors, don't solder things to your Arduino or your ESP32s. Solder it onto a board. Make sure you can then just plug your units in and out. That way, if you have to replace one or anything like that, your project's going to be good and you can just take these boards off as and when you want. Now, once you've built your project, one of the things you need to think about is what are you going to put it in, and there are some things that you need to start to consider. Obviously, are you having an internal or an external power supply? So this is a very, very big project case. This is housing an ESP32, I think it's an Arduino Mega. Both of them have got shields. There is a motor driver in there, and there is a computer power supply that's powering all of this. You can see I've got extra outputs on the back. So this power supply is not only powering the boards that are in there, it'd be a bit excessive if it was just doing that, but off the front comes the connectors to a model railway. But as you can see, this is a big, heavy project case. The front I replaced with a piece of machined acrylic. I just happen to have some lying around that I can use. So that's what the front is. But as you can see, this is actually a metal case. That means it can really take some bangs. And these are things that you need to think about. Bits, dust, dirt, water, heat, cold. Where is your project going to be? I've got projects that are in my garden, so again you have to think about, it's got to be waterproof, dust proof, these things. Just think about what you're doing. Some projects, I did one recently for a guy's solar project, and it's actually mounted in an old plastic food container. It's in a reasonably safe position and it's working fine. It doesn't need to think about anything excessive. Bits to think about on this one, obviously on the side of the case there's actually cooling areas on here. Again, depending what components you're using, you need to think, do they generate heat? Now for this next project, this is a different type of container. Again, I've used some acrylic on the front, machined out a space to get a touch screen on, a couple of rotary encoders, and then I 3D printed a case to go with it. Power supply. On this one I'm using a USB-C connector. So this actually, on my model railway layout, I've got USB-C plugs on the front of the baseboards. I can just plug straight in to the front of the layout. But internally you can see this one has an ESP8266 D1 Mini. It also has an Arduino Duo. You can see it's got a great big prototype shield on here with a ribbon cable that's then going onto the back of the touchscreen. So this was a fully 3D printed project. It is a pretty tough case, but these are the sort of things just to think about as you're building your project. What are you actually going to put the item in? Sometimes you can just find odd project boxes that will fit. You can buy them online, or if you're like me, you can 3D print them or machine them out of whatever you want. But a project box is important, especially if it's in a nasty environment. Let's face it, with a project like this, if I left this out in the open, these wires are just going to get caught. And again, think about your wiring, think about your wiring runs, stuff like that. I should be doing another tutorial on wiring to do with model railways, because for those who model railways, especially those with DCC, there are some things that you need to think about with your wiring when it comes to electronics. Now, one final thing just before we close. This particular bit of wire, this cable, didn't really come out very well, the focus on it. These cable wires here, the internal diameter, you know, 0.5 millimeter to 1 millimeter. You'll notice here I've got some tiny wires that are inside this grey one. They've got some thicker wires as well. Just something to remember. If your component draws a lot of power, then the wires need to be thicker. Now you can look up online how thick a wire needs to be depending how many amps the component is drawing. Most of the stuff we do with Arduinos, you know, we can get away with these thin wires. That's why we can use those thin breadboarding wires. However, if you remember at the beginning of the video I showed you how I burnt my breadboard, that was because the stepper motor I was using a lot of amps. You know, I probably was using 1.5, maybe even 2 amps at one point on that thing. Just be aware, if you start to put a lot of amps down a very small cable, things will get very, very hot very, very quickly, and you can cause yourself a fire. So if you're starting to use bigger components, heavier motors, stuff like that, just think about the wiring that you're using, and again, make sure that your power supply and everything is suitable. For power supplies, they're pretty easy to get hold of. If we go back up to my breadboard, this power supply, you know, it's one of these plug-in things. I forget what it came off. I have got a box of these things. I've got them off old modems, router boxes, basically anything electrical that comes with a plug-in power supply, laptops, you name it. When the device falls apart, I keep the power supplies, and I'll just cut the plugs off the end and reuse them. Just check the voltage and the ampage of them to make sure they're suitable for your project, but keep a box load of them because they're very, very useful. Anyway, I hope that has been useful to you. Wiring, it is a pain, especially when you're on the breadboard. Be careful that those wires are in place. Make sure you've followed the diagram correctly, and if your wires are coming loose, there's 2 ways you can do it. One, you can do the blue tack method. The other way is you can bend the end of the pin very slightly with a pair of pliers Don't use your teeth. Bend the end of the pin very slightly so that it isn't straight. Then when it goes into the socket, it tends to grip a little bit harder. But I hope that's been useful to you, and if it is, please click the like and subscribe for the next projects. Bye for now.